Hi, good morning. This is to include some instructions about Fourier synthesis, our lab for this week. I will just share with you my screen going for the course where you will be able to access the material. This is here some information about how we synthesize the square wave and the sawtooth wave. This is not, I will say, just read it. I will not go over it today. This is the instructions, the main instructions, and here, if we look at this one, this is the main instructions that I will summarize for you. Also, okay, let me see again. Okay, this one here is again more instructions, but everything here I will I will include it in my instructions. Just of course read these carefully so that this is how I'm gonna grade the lab. Okay, now one more thing. This is what you're gonna submit, and this is gonna be due this week. And one more thing I want to share with you is that I maybe summarize the instructions here. I will go over these. I will share this file with you, but you will not have access to it. Okay, and then let's start with this one here. Okay, now I'm just summarizing the theory, everything about this lab, and how we are going to do the exact steps, like instructions. Okay, then I like most of the time to have it actually downloaded. Of course, like the title here is going to be Fourier Analysis Lab. This lab, you need to submit only the Excel sheet. Okay, then no abstract theory, whatever, we used to, because this one is mainly working with Excel. Now, what is really Fourier synthesis that we are going to deal with today? It is the opposite of Fourier analysis. Fourier analysis, when you have breaking down a waveform into its components, then any complicated wavefront can be actually simplified by saying it equals this harmonic plus this harmonic plus this harmonic plus this harmonic. We use these widely in analysis of sound and many areas. Today we will do the opposite of analysis. We will go to Fourier synthesis. We are going to try to synthesize a square wave and a sawtooth wave. And then we are going to recreate a waveform using wave, like we call them harmonics. And we call this superposition of waves, which means you are going to add the instantaneous amplitudes for each one. Anywhere, any wave can be written as fx equals, this is a term, plus this is the cosine terms, this is a constant, this is a cosine term, and this is a sine term. And you can see here there is what is called the amplitude, AN, BN. Now, we know that this is fx, it's a periodic function, repeats itself, then fx equals fx plus 2L. 2L here is representing the wavelength of the wave. Today we will use x, like sometimes we can use x, we can use t, our variable. Today we will use our x as a variable. L is going to be half length of the wave, which is half of the wavelength. H0 over 2, we call it an offset bias, a term that is a constant that is going to shift the wavefront up or down. We will not use it in our analysis today. The function here, fx, defines the position of the point on the wave when we have lambda equals to L. Now, the harmonics are really multiples of the fundamental frequency for a wave that has a wavelength of 2L, and these harmonics are going to be n equals 1, 2, 3, 4, 5, like they are going to be a set of numbers. Now, for the practice, we are going to use only, just one, but we will do like 20 harmonics for the sawtooth and for the square wave. Now, this is also background of a theory where I'm just showing you the origin of like the amplitudes, how they can be calculated. We will not do this, but we will use today two wave functions, the sawtooth and the square wave. I'm going to expect that you are going to, by the end of today, you're going to have, after you created your harmonics and add them, one of them, the sawtooth, is going to show similar to this one, and the square is going to be this one. Okay, now let me show you here for the practice. We're going to practice with a sine wave, and we are going to have the amplitude of the wave as 3, and the harmonic number is 1, which means it's going to repeat itself just 1, and the amplitude here is 3. And just I'm going to show you in Excel how you are going to, create these numbers and how we are going to do this. Then I'm going to move to my Excel, where I have, okay, this is my wave, this is my finalized word. Let me do the following. I'm gonna go for here, add another one. I'm gonna say this is gonna be my practice for today, so that I will show you what we are going to do. Let me reposition this also. And I will say the first thing we are going to do is that we need 13 indices, but just the first thing I'm going to say, I'm going to write here, this is the amplitude and equal, and I'm going to add this here. Let me add it to the C. Okay, I'm gonna have my amplitude as 3, and the second one is, I'm gonna say this is the harmonic number, which is related to the frequency, how many of them you want to see, and I'm gonna say this is 1. Now for the indices here, I'm gonna write indices. I'm gonna start from, okay, let me have this a little bit bigger. Okay, I'm gonna start from 0, and then 1, 2, okay, and then I will highlight these, go down for 12. All right, now, okay, the next one, I'm gonna create my X. For the X, you're gonna enter equal the indices times pi, which is the function pi, okay, and then you're going to divide by here, you are going for this one, you are going to divide by 12. Here I missed my 2. Okay, I said A6, the indices, of course it should be 2 pi times 2 times pi divided by 12. Okay, and then here this is gonna be my numbers, and you need to check that this here is 2 pi. It should be here, that number, which is 6.8318530.7. All right, now I want you to adjust this to 9. Okay, format cells 9 decimal places, have that as 9. Okay, and then here I'm gonna create my F x, which is the function that I'm looking for. Your function will be equal to, I want to have first the amplitude, and then here the amplitude is C2, but I wanna see if I will be like adding these dollar signs so that I will be able to change the amplitude, and this is gonna reflect on my function. Okay, if you did not put the dollar sign, is gonna take the next number, the third number. Here I wanna maybe I will say lock it to the amplitude for all of them to be the same amplitude times. Now I'm gonna have the sine function. Okay, I want to, okay, here I'm gonna multiply times sine. This is the sine. Okay, and then here you're gonna have x times, okay, the frequency number, which is this one. Also I'm gonna add the dollar sign thing. And then I'm gonna close the parentheses. Yeah, I need only one of these, the dollar sign. Okay, you don't need both. Okay, you know, sometimes I put that, you know, it will be accepted. And then this is here what I have for my function. Okay, then these are I have calculated the function. Then look again here how they removed the second one that I have here, the dollar sign is not needed. Yeah, I think like sometimes I will put it before the letter is gonna work again, but that is enough to lock it, just one dollar sign. Now I want to graph, and for graphing you will use the line. Okay, then this is the one, the line. Okay, that is the one. Okay, and let me see here. I'm gonna first select the data, know that I have everything. Okay, this one, okay, this one is not working, not this one. Got it. Okay, I will insert why I have it. Okay, let me see here. I wanna have that one. Okay, just I want to select the data here for the y and for the x. Why it is distorted? This is the one. I should have the line one. Oh, that one. I'm sorry. I did choose the wrong one. It should be insert. Let me repeat that for you here. Okay, insert. You don't go to scatter plot. You're gonna go to this one. Okay, and here, just I want to be sure that everything is okay, and then I will say, okay, let me just fix my data here. I'll say the practice waveform, and for my x values I'm gonna have all. There is something wrong with my and this is equal the y's. Okay, and then here, okay, now I'm okay. Okay, then this is really the wave that I have. Now I should move this to another you know, chart. Okay, a new chart, and then I'm gonna say okay, and then now I have it here. Okay, and of course just the quick layout, the things that we used to do. Then here you're gonna say fx, and here you're gonna say x. Okay, then this is here. I have finished the first one, which is the for the practice. Now also I can show you here that I summarize these steps in here for you. Okay. Now I will move to the second part, which is to create the sawtooth one. Okay, and the sawtooth here is I will create here the amplitude, and for the amplitude you're gonna have this cell, and here you're gonna have the frequency. Now you are going to work first on your frequencies, and the frequency is gonna be started from 1, 2, 3 till you end up with a 20. Okay, this is a 20. Then here what you have is you're going to have the frequency from 1 to 20, and it's going to be steps on 1, 1, 2, 3, 4, 5. The amplitude is going to be created using the frequency 1 over the frequency. Then this cell is going to be here 1 over C3, which is 1 over 1. This one is going to be 1 over D3, which is 1 over 2, which is 0.5, and that one is going to be 1 over 3, which is 0.003. Again, here for the indices, this is the indices. We're going to start from 0 to 256. You're going to create it the same way I did. For the indices, for the x here in radians, you're going to have the A5 here, which is the index, multiplied by pi times 2, which is 2 pi divided by 256. Now you are going to create also your sine wave here. By now I want to use this amplitude, and I want to use this frequency times x. Okay, because B5 is my x here. Then it's going to be the amplitude times sine, the frequency number times x. And then you are going to apply this for the whole thing. You're going to scroll down and create this for all the indices. Then we are going to move to D1 here, which is the amplitude 0.5 multiplied by sine, and then again the frequency number times x. You're going to continue doing all this until you will have something, you're going to call it sum, where you're going to add all the, all the things coming from this row. Then for the first one is going to be all the zeros. The second one is going to be all the, 6 row, which is C6 plus D6 plus E6, and go on. And finally, you are going to graph the sum versus x. And here I can show you that this is going to be my graph here. Okay, let me show you here. I will go to sawtooth here. I'm gonna have my total. Let me show you. Okay, my total. Insert. I'm gonna go to the line here, and I want to be sure that I have the data correct. For my x values, I want to use my x values here. And for my y, it should be that column, that's correct. And then this is my graph. All right, and this is a sawtooth. Now, the only difference with the square wave is that you have also the amplitude, the frequency. You're going to create things the same way, but the thing is that for the frequency, you're going to have the numbers 1, 3, 5. You will skip the even numbers. They're going to be all the odd 1, 3, 5, 7, 9, 11, and you are going to create also 20 of these. And then finally also you're going to graph. You're going to add all the 20 harmonics. You're going to let me see here why I have the last one. Okay. Then I'm gonna graph, just show you how is gonna be the shape of that graph here. Insert, and again go to the line. Again, I can check that I did select the correct data for my X. Okay, where is my graph? Insert. I lost my graph. It's here. Okay. Then select data. My X, just to be sure that they are really correct. And of course, again, you're gonna move it to another. Of course, we can improve the quality of the wave here by adding more harmonics than 20. You can make them 40. Oh yeah, and of course that can be done, of course, using computers. Thank you very much and have a great day. Don't hesitate to contact me for any issues with the lab. Thank you.